Imagine you ask two people to measure the same room. One uses a laser, the other uses a tape measure. They get different results, but neither of their tools are broken. That's basically what's happening with the universe right now. The universe is expanding. We've known that since the 1920s. When Edwin Hubble, yes, the telescope guy, first noticed that distant galaxies are moving away from us. And the farther they are, the faster they move. The number that describes how fast the universe is expanding is called the Hubble constant, written as h subscript 0. It's measured in kilometers per second per megaparsec, which is a very physicist way of saying for every certain distance you travel out into space, galaxies are flying away from you that much faster. Simple, right? When scientists measure the expansion rate by looking at the early universe, specifically the cosmic microwave background, basically the afterglow of the Big Bang, they get a value about 67 kilometers per second per megaparsec. But when they measure the expansion rate using the local universe, actual nearby stars, supernovae, things that we can actually observe today, they get a completely different answer at around 73. That's not a rounding error, that's a gap of 4 to 6 standard deviations, which in science means it's almost certainly not a fluke. Both methods have been checked, rechecked, checked again, by independent teams, scientists using completely different instruments, and yet they still disagree on every single circumstance. The disagreement is called Hubble tension, and it's one of the biggest unsolved problems in modern physics. So what's going on? First, somebody made a mistake. Maybe there's a tiny systematic error hiding in the data that no one has found yet. Scientists haven't ruled this out, but after years of searching, nothing has turned up. At least, not yet. And the second option, and this is the cool one, our model of the universe is incomplete. The standard model of cosmology, called lambda CDM, also meaning lambda cold dark matter, has been very successful. It explains the large-scale structure of the universe, the abundance of elements, even how galaxies form. But maybe it's missing something. Maybe there's a form of dark energy that existed in an early universe and then faded away. Maybe gravity itself behaves differently at cosmic scales. Physicists have proposed over 1,000 different solutions in the past few years alone. Here's why this matters. Even if you'll never personally need to calculate an expansion rate, every time science hits a wall like this, a measurement that simply doesn't add up, it's historically a sign that something massive is going to turn out of this. Anomalies like this gave us quantum mechanics. They gave us general relativity. The Hubble tension might be pointing toward the next revolution in how we understand space, time, and the universe. We don't know what the answer is yet, and that's not a failure of science. That's just simply science working. The universe has been around for about 13.8 billion years. It's kept a lot of secrets, but it also loves clues, and right now, 2 of those clues are pointing in complete opposite directions. Figure that out, and you might just rewrite physics.